So, next question. A monochromatic light of wavelength 632.8 nanometer is produced by a helium neon laser. The power emitted is 9.42 milliwatt. Okay. So there is a helium neon laser and the monochromatic light produced, the monochromatic light coming from the helium neon laser having a wavelength lambda is equal to 632.8 nanometer. That is equal to 632.8 into 10 to the power minus 9 meter. You have to convert it into SI. And the power emitted is given as not momentum. This P represents power. Okay, so the power I'm using capital letter P for power. So power P is equal to 9.42 milliwatt. That is equal to 9.42 into 10 to the power minus 3 watt. Then first sub question is find the energy and momentum of each photon in the light beam. Okay, you have to calculate the energy and momentum. So we know that we have only two values, which are the one is lambda and another is the power part. Okay, but if you know the value of lambda, you can calculate the you can calculate the energy. Okay, so that energy is equal to h nu, that is hc by lambda. Okay, h value, h value is a constant that is called a Planck's constant, 6.627 into 10 to the power minus 34 joule second. C value, velocity of light in vacuum, that is 3 into 10 raised to 8 meter per second. Those two values are constant only. Then you can substitute the value of HC and lambda in the given equation, then you will get 6.627 into 10 to the power minus 34 into 3 into 10 raised to 8 divided by lambda is 632.8 into 10 to the power minus nanometer. Okay, minus 9 meter. Then after solving this, you will get a value of energy. Next question is they're asking momentum of each photon. So momentum is small letter p is equal to mass into velocity. Okay, and there is no velocity given in the question. So this time, if you want to find the momentum, you have to know about an equation. P is equal to h divided by lambda. Okay, P is equal to h divided by lambda. So I am going to write the equation here. P is equal to h by lambda. This is the equation connecting momentum and wavelength. Then you can substitute the value 6.627 into 10 to the power minus 34 divided by 632.8 into 10 to the power minus 9. Then you will get the momentum value. So this is the first part of the question. This is the second part of the question. And the third part, this is first and second. Okay. These are the first two parts of the question. Next, in the second question, they are asking how many photons per second on the average arrive at a target irradiated by this beam. Okay, they are asking how many photons per second or how many photons are irradiated. So at the same time, if you have to find the number of photons, okay, so the number of photons, there's an equation there. That equation is number of photons per second is equal to power divided by energy of each photon. Okay. The number of photons per second. Number of photons per second is equal to number of photons per second is equal to power divided by energy of each photon. energy of each photon. Energy of each photon. So you can substitute the value. Power value they have given 9.42 milliwatt. 9.42 into 10 to the power minus 3 watt divided by energy of each photon is 3.14 into 10 raised to minus 19. Okay. 3.14 into 10 to the power minus 19 is the value. How did you get this answer? Because energy equation is equal to H nu. Okay. After solving this, you will get the answer. That is 3 into the 3.14 into 10 to the power minus 90. Then again, you will get the number of photons per second. That is the second part. And the third part is how fast does a hydrogen atom have to travel in order to have the same momentum as that of photon? Okay, so we have to find the speed of a hydrogen atom have to travel in order to have the same momentum as that of photon. So this case, what you can do, P is equal to mv. There is an equation connecting momentum and velocity, that is P is equal to mv. Okay, P is equal to mv. Then from the equation V is equal to P by m, you can write. Okay, so P is equal to mv. From this equation, V is equal to P divided by m. P is the momentum. Momentum value you will find divided by mass of the particle or mass of the photon. So mass is equal to mass of electron is 1.6 into 10 raised to minus 27. That is mass of electron. Okay. So 1.6 into 10 raised to minus 27, you can write here. Then you will get a value.